second session. Welcome back, everybody. The second session is somehow special to this conference because I think it's the first time that the decision was made that more speakers should get the chance to present, and therefore the time per speaker had to be reduced to 15 minutes, including hopefully 1 or 2 questions. So that is why we should do our best to stick to the schedule and to keep up with the time. So therefore, I will not make much more introduction here. Welcome back, everybody. Our first speaker is Mr. Roland Berger. He's a general manager at Honda, and he originally came from engine design, but also worked in the marketing department and is now responsible for European product planning in Honda. And this position seems obviously to be linked to the topic that he is going to present to us with swappable battery stations to boost electric motorcycles. So the stage is yours.
Good afternoon to everybody, ladies and gentlemen. Sorry, right after the lunch break, so I have an easy topic, not so dramatic. I try to be in these 15 minutes, and let's talk a little bit about swappable batteries. Basically, you know that electrification will be everywhere. It is one part mandated, like the EC Commission. It is other part, like in India or so, one solution necessary because the pollution is quite high. So in order to do so on the two-wheelers, we probably need a little bit a different approach than the car side, because we cannot fill 600 kilo batteries to a motorcycle, or at least not easily. So what we try is to have some kind of key success factor, extending the range, shortening the charging time, and also lowering the vehicle cost and the infrastructure cost. Let's run this a little bit. It is self-explanatory, I hope. So faster than this can be shown in 40 seconds, you can swap a battery from a vehicle, from a roadside loading station you see in the background to the vehicles you see in the front. This is the basic idea, which also has to do that motorcycle industry is not entirely sure that the car loading infrastructure will ever reach the levels required by the car industry. So we thought a different idea probably necessary. The idea was already used in Taiwan or in Japan, also tested in some of the areas, to do this with an interchangeable swappable battery. Interchangeable means you move this battery, alphabetic order, from a Honda, put it to a Piaggio, the same battery, put it into a Yamaha, or even in a Neo or Kymco. There is no significant disadvantage for rider because actually it's faster than refueling. The charging is faster, as I said, than the refueling, and it is also an attractive business model already existing in the B2B segment in some cities, also for business to customer. And even if you think about it, in best case, you charge a car in 30 minutes to 1 hour to a certain percentage. We can with the swap do the same in 40 seconds. Of course, there is also the society. For customers, you have the possibility to drive electric with longer range and many other advantages. It is also for the environment because it is zero emission. And as it is swappable batteries, you also have the access to the battery for the upcoming recycling regulation. And for the manufacturers, because it is all the same battery, and the cost of the battery hopefully will decrease. Recently, it was more on the different side, increasing. And then, of course, you have the cities. And the cities are the major driver for electrification, sometimes like Paris, much faster than the EC Commission demands, or some faster than the actual possibilities of industry. And in order to do so, we really try to work together with cities and also see their demands and how we want to move forward. And we will do very soon city tests to find the real usage of the vehicles. Why do I say real usage? It is not the same traffic everywhere. While in Japan you have more 150cc equivalent, so moped, common word. In Southeast Asia you have 70-80cc equivalent, while in Europe you have 1 to 5cc equivalent, which simply means that on a city highway you have to drive for 10 minutes more than 100 km per hour, and your battery has to be able to do this, because otherwise you will not be able to pass any truck. What is our task? Develop a common technical specification of the battery system. Common means real common. Define the common system usage and system of the swapping system. Make and promote the consortium specification to be finally, because this is a task, an international and an European standard, and expand the use of the consortium's common specifications also to global level. It is a bigger task, and we work hard on it already since quite a period, but we are moving forward and we have already achieved some good results. What is the core requirement? Suitable for every L category if you want, from L1, moped, to L7, which is more than 2 wheels, and also different applications. You see on the picture here one application. This is rickshaw in India, which also can be done like this. It is a portable battery with a maximum weight. The battery is within the class A limits, so it is 48 to 52 volt and not high voltage batteries. And you can use single or multi batteries. You will be able to use 1 to 8 batteries, and also you can use them parallel or in series. In the standardization scope, we have, of course, the external geometry has to be all the same size, otherwise it would not fit. We have to do the connector. You see some examples on the side, but you also cannot forget the communication protocol with vehicle and swapping station has to be all the same. And electrical, mechanical, and last but not least, safety requirement, because actually, easy to say, we do not want to burn. This is our action plan. You can study it later if you're really interested in it. We are close to the standardization and have started now. We start this autumn with the first prototype testing, and within 23 we hope to finish most of these things in good shape to be able to then later on roll out on the real road with the manufacturers. Now, it is easy to say so. On this picture, in the beginning, you have seen 4 manufacturers, the founding manufacturers, Honda, Piaggio, KTM, and Yamaha. In the meanwhile, we have grown much further. You can see Kymco or Polaris, many startups, and also from the loading infrastructure, a German company, Swappable, which makes loading for different kind of batteries and is very helpful in the starting point. So far, all I tried to explain you from swappable batteries, and now I'm open to any question you may have. Thank you very much.
Thank you very much, Roland, especially for perfectly keeping the schedule. So, Fefti, the first question from you, please.
So, Fefti from Robert Bosch GmbH. So I can understand from technical perspective, it is possible to solve it. I also understand the necessity to bring the standard in order to scale this technology. My question is, if I think a country like India, who should make this big invest in order to bring these batteries to all the stations? How is the commercial side? How is the concept there? Because without having a commercial concept, I think it is very difficult because we're talking about very high in cost.
The Swappable Battery Consortium starting point is the standardization, because this you need to do first. Because actually, especially in Europe, the antitrust regulation is a very dramatic one, so we cannot easily do all of these things together. But the second step, after we have found the technical specification and tested, we will also go to the second step about commercialization. And of course, there are ideas that whether the real vehicle owner is battery owner, whether the loading station owner is battery owner, or actually there's a third party, but also this will be addressed, but not in the first step. Also, we of course have laid down what is the necessity later on, because also your communication protocol need to take care about such kind of things. We consider it, but it is not the first task.
Okay. Thank you. Is there any other question from the audience or from the online audience? If not, maybe we can close with one last question from my side, because I think the possibility of actually swap a battery in a vehicle, I just can't imagine power two-wheelers to do this really. So this seems to be a big advantage for the world of power two-wheelers. And would you think that we can even, let's say, gain new riders by that possibility?
We first of all hope to keep our existing riders, but yes, we may gain new riders, because there is especially a young audience which is much more environment conscious that the ordinary two-wheeler customer is. Mm-hmm. And in order to address these, swappable batteries may have a part. And there's it's maybe not for the highway, but as the city space in historical European cities is limited, you cannot erase the Buckingham Palace or such kind of things. Two-wheelers with much less space requirement is for sure a future possibility. And if we stake in London, London wants to be the fastest one, and they already have a zero emission zone in the city, which decreased the overall emission by 20% to their press release. We don't know whether it's really like this, but anyway, you will see that it is not only a must for the industry, it's probably also a future market. And if you think on the last mile delivery into city centers, with rebuilding in some cities of the road to make it smaller, this will be also one market which could be addressed by two-wheelers, not necessarily by bigger trucks like it is now.
Thank you very much.
Thank you very much. And I wish everybody a nice next lesson in good technology. Thank you.
Thank you. You could even still join us if you like, but it's also okay. So, but we can proceed, and we will proceed with Dr. Jolyon Carroll. He's a biomechanics specialist at Autoliv Research, and with his former work at TRL in the UK, he brings along more than 20 years of experience in the field of biomechanics of vulnerable road users. And the work presented today deals with the relation between motorcyclist injuries and motorcycle, as well as crash types. So please.
Yeah, thank you very much for the introduction, Sebastian. But before going any further, I should acknowledge my co-authors, also from Autoliv Research in Sweden, Fritjof Gideon and Niels Lubbe. And here in the audience somewhere, Matteo Rizzi from the Swedish Transport Administration. So thanks for their part too. I've got a slim outline to my talk to you today. I'm going to spend a couple of slides thinking about an introduction and a few slides on method. And then I know it's a heavy topic after lunch, but I'm going to dive into thinking about the injuries and look at distribution across body regions and some priorities for prevention in the future. So by way of introduction, you'll know that within Europe, if we need high-level statistics on collision data and road traffic crashes, we can look at CARE, and the data are available through the Eurostat website. And from time to time, the European Commission themselves even publish reports. Actually, here's one from the European Road Safety Observatory. And it's very quick and easy to learn that, on average, 15% of all road traffic fatalities in Europe are to power two-wheeler riders. So those facts are already out there, and we know a lot about them. One of the things that those data do, which is quite interesting, is they separate out motorcyclists from moped riders. And so far, I haven't done that yet, or we haven't done that at Autoliv within our injury prediction work. So we've published on how motorcyclists would be injured and their injury priorities in car collisions, if you hit an object, if you fall to the road. But we haven't split that out by power two-wheeler segment. And so that was really the basis for this work and for this study. Now, I don't need to tell this audience about GIDAS. We've had a nice introduction to that already today. Yes, that's right. It was takes cases from Hanover and from Dresden regions. Yeah. Okay, thanks. Good. Apologies. Yeah, and for this study, we took a collision set from January 2022. And in particular, these are fully reconstructed cases. They're motorcycles of type L1E and L3E. And we looked at the main rider, the driver of the bike, not the pillion passenger. And also importantly, we've excluded cases where the helmet wearing status was not worn. And also in this study, I'm going to refer a lot to injury scale and injury classifications. And for this, we've used the abbreviated injury scale as published by the Association for the Advancement of Automotive Medicine. I'll be looking at both AIS 2+, that's at least a moderate injury outcome, or AIS 3+, that's at least serious. And as you'll see from the bottom left of the slide, within this scale, there's lots of information. So we could look at position of a femur fracture, whether it's on the shaft. We might know if it's complex. We might know if there's an open wound over the top. But for the purposes of talking to you today, actually I'm going to truncate that and just think about, was it a lower extremity injury? Was it to the femur, that body level region? And the last thing to introduce in terms of the method were these three groups. And this is the focus for the work. So we've split out three groups, and on the left, the purple, these can be riding any type of motorcycle, but importantly, the GIDAS coder has said that they fell before they had another collision. So they were falling or sliding as their primary event. And then on the right, the two groups, the light blue and the dark blue. The light blue is they were upright at the time of crashing. So they went into free flight, or they were scooped up by another vehicle, or there was a collision without scooping. And for the light blue, that's the scooter riders. We know that they were on a scooter type of motor powered two-wheeler. And comparing against that is upright everything else, whether it's chopper, tourer, sports bike, whatever. And in terms of the kind of descriptive statistics overall, here are some things that kind of set the scene, so I'm going to take a little bit of time to go through these. And you'll see the numbers of cases and the numbers of riders differ across the groups. When we look at the number of injuries, you can do some simple maths to help you. On the left, the falling, sliding, 800 riders, 1,800, at least moderate injuries, multiplied by 2, so to speak. Upright scooter, again, it's almost twice as many. And then on the upright, any other motorcycle, it's a bit more. So we're building up a picture that the upright motorcycles might be having more severe crashes. That's borne out also by the number of seriously injured riders, where the factor is a quarter for the falling, sliding. It's about a quarter for the upright scooters, but it's about a third for the upright motorcycles. So this group of upright motorcycle crashes is a bit more severe. We also had a look at the ratio of urban to rural crashes, and it's 2/3, 1/3 for most of these falling, sliding cases. But for the scooters, they're used more in urban environments. And also that bears out on the travel speed at the bottom, the travel speed before the event, where the upright scooter crashes had a lower travel speed. So that group's a little bit different again. So that's some general background about these cases. And now I'm going to dive really into the detail of the injuries. So you'll have to excuse me. I'll try and help you through the figures. Here are some graphs. I'm going to come back to these. On the y-axis, the vertical axis, it's the number of injuries. It's the absolute numbers, We've got different numbers of riders and different numbers of injuries, so watch out for that. The scales will change. The important thing is the height of the bars. And the x-axis is body regions: head, face, neck, spine, thorax, abdomen, upper extremity, and lower extremity. And overall, the shape of these two figures looks quite similar. The priorities are lower extremity, upper extremity, head, and thorax. Okay, I think that's pretty usual to see. The differences with the falling sliding cases is that we have many more upper extremity injuries and we have many more thorax injuries in that case. So those bars leap up in terms of their importance. And this slide picks out the top injuries, the top 5 injuries at this at least moderate severity. And across all 3 groups, the number 1 is cerebral concussion. So this is a brain injury, it's a concussive brain injury, and it's a moderate by nature and severity. So it's the first entry level into traumatic brain injury. That's the number 1. And then after that, we see some differences emerging, whether it's a trunk injury to the falling case, clavicle fracture, or a fracture to the rib cage. And compared with equal second for the upright scooters, a tibia fracture, that's the lower leg, or a femur fracture in the thigh. Looking at the next severity level up, AIS 3+, at least serious, then this takes off the blue from the previous figure, but you're same numbers. Again, there's similarities between our upright crashes. There's a bit more red on the right-hand side, so they're having more serious events. But again, we'll see with the falling sliding that there's much more involvement of the thorax. Borne out again when you look at the top 5 injuries. So the falling sliding, we have fractures to the rib cage, injuries to the lungs, cavity injury, all to the thorax, whereas upright scooters, it's the femur fractures that dominate. So to conclude, in many ways, the injuries are broadly similar across all of these 3 groups, whether you fall before any other collision or you have an upright crash case. I'm going to tell you that the head, lower extremity, upper extremity are important. And looking at this serious injury level, then it's going to be the head, lower extremity, and thorax. I mean, those groupings are consistent across any of this analysis. However, some important differences exist, and those are emerging now. So femur injuries were more frequent for upright scooter riders than for other types of motorcycles. And interesting, when we looked at the contact causing the injury, as coded in the Gidas case, the majority of those femur fractures were said to originate from contact with the car, not from the rider's own power two-wheeler or the ground. And despite wearing helmets, power two-wheeler riders still sustain head injuries. And in fact, the riders of the other motorcycles have more head injuries and have more serious head injuries. So this gives us my takeaway, my focus then going back to work, and what I wanted to tell you all today. That it gives a particular focus on femur protection for these upright scooter cases and head protection for other types of motorcycle riders, both at the moderate level, where they're very frequent, and at the more serious end of the spectrum. And that concludes for my presentation, so thank you for your attention.
Thank you very much. We are perfect in time, so we can definitely allow for one or the other question from the audience, maybe. The biomechanics specialists in here. So, if not, maybe I can ask a question a bit coming from another academic background, let's say. When I imagine the category motorcycle, I imagine a huge variety of types of vehicles, from a big touring bike to a super sports bike and so on. And my question would be, what do you think makes the difference between the vehicles within that huge category motorcycle as compared to the category motorcycle against scooter?
Yeah, and that's an excellent question. And it's at this stage, it's very difficult to be precise about that. the way my mind goes, I immediately start thinking about frontal crushes and whether you've got a fuel tank between your legs or whether in a scooter rider there's nothing there and you're in more of a kind of step-through seating position. But of course in here we haven't yet broken down the different crash modes, so it could be that it's just side impacts as well. So in these upright crashes, then I think it's more about overall severity level at this moment in time. And that's why you'll see such similarity between the upright crashes. When something does leap out, like femur fractures, I think that's really of interest because there's clearly something a bit different about those scooters. Compared with the falling off and sliding, which is a different overall event kind of mechanism.
Thank you very much. So if this has not inspired any other questions, I would say, no, it's good that you stay with me. Thanks for that. So thank you very much for your presentation, and we are perfect on the schedule to invite our third speaker of this session, which is Professor João Pinho. And he has a very interesting and manifold background. On the one hand side, he has been a full professor and member or even president in different societies related to the topic of renewable energies. And even if officially retired, he is still working as a senior visiting researcher in that domain in Brazil. And on the other hand side, he founded the My Way Motorcycle Safety in 2016 with the aim of spreading information on motorcycling. And I would say this is exactly what brings you here today. And we are very much looking forward to your speech on rider training.
Thank you very much for the introduction, Mr. Will. Good afternoon, ladies and gentlemen. I'm happy to be here for the second time in this conference. And what led us to prepare this course? We see that there are many rider assistance systems today which are very important, which are wonderful. We have seen some of them in the morning. And we also have a problem with that because many people, unfortunately, many people think that the rider systems will do everything for them. And I've heard many times people say, my motorcycle has ABS or CBS or whatever. And they think, I don't need to practice braking. Now, another important thing is that many motorcycle schools, especially in Brazil, but I suppose it's not very different all over the world, they just don't pay attention to if the rider really learns. They just want them to pass the driver's license examination. And as a result, many riders are there with minimum skills and always having problems with accidents for themselves and for the other participants of the traffic. And so, even when the people think, well, my skills are not very good, so I will do an advanced course. Many advanced courses, and I have taken a lot of them in Brazil with BMW, with Triumph, with Harley Davidson, with the police, and in the United States also. They just pay attention to the practical part. And they say, when you brake, you cannot swerve. But they don't say why. They don't explain why. And many other things. So I think the theoretical part is as important as the practical one. So, and I've seen that in the courses that I've instructed in Brazil, that when the people learn how it works and why they are doing sometimes types of exercises, they do it much better, they do it fearless, especially leaning the motorcycle or braking in on wet pavement, for example. And that's the concept of the course. We have basic to advanced training using our own place there that we developed exactly for that. We have both on-road and off-road. Here I'm going to speak only about the on-road. And we introduced the concept of preventive riding, which is different from defensive riding. It comes before. Because when you talk about defensive, you are already defending from something. And the prevented riding concept is to avoid to go into the defensive riding procedure. So we teach the motorcyclists how to proceed in real situations on the road. And we have our place, and we teach people from 1 participant to 5 because of the size of the place, and also to pay attention and to adapt the exercises to the rider's needs. As I said, 2 parts, and I have already said that, so I'll go on. Our training center has 2 parts, on-road and off-road, and also some facilities for the people to rest, hydration, and so on. And we have a YouTube channel that you can see in these links there, some of the exercises that we made there, some of the courses, and there are also other exercises and other videos, all of them on motorcycle safety. These are some pictures. We have a shed for the people to rest and for hydration, and we have the paved part there. You see the paved part is all painted with markings, each mark in a different color. Each color, it's a different exercise or different groups of exercises. And during the rest period, we make one group of exercise, then we rest for 15 minutes for hydration, etc. And a helper comes and puts the cones for the next group of exercise. We always have an ambulance with an intensive care unit there. Thanks to God it was never necessary, but that's it. The theoretical part is composed of 14 topics. I'm not going to go through each one of them because of the time, but you can see here the most important thing is the first one, which is the basics of motorcycle physics. Then you have a lot of things. Another very important thing is the 3 A's rule, which is attention, assessment, and action. Then we have the correct use of the motorcycle and rider resources. We use an acronym COFRES, which means safe for saving money in Portuguese. And each letter stands for 2 parts of the body or the motorcycle. For example, the C is for cerebro, brain, and for cabeça, which is head. So how to use your brains and your heads, and so on. Then the techniques for slow speed maneuver, braking techniques, cornering, which is, these 2 topics are the most difficult that we see the people having, and the concepts of preventive riding, and so on. These are some examples, pictures, instructing the people in the theoretical part, the motorcycle movements, cam circle, and friction, and we use motorcycle models, we use bicycle wheels, we use even brooms to show the physics of the motorcycle. Then we have the practical part. It's 22 exercises. Sometimes we don't use all 22, but we divide them in groups, and between each group we have an interval for resting and hydration. That's when the helper goes there and changes the cones according to the markings for the next group of exercise. One of the most important exercises that we do there is number 3, which is the throttle, clutch, and rear brake control. It's the one, the most important, I would say, for all other exercises. The size of the slaloms and the circles depends on the motorcycle types. If it's a smaller 150 cc or if it's 1200 cc, then we have according to the motorcycle, and also sometimes according to the rider's ability. This is the other set of exercises. We have a lunch break, and during the lunch break we go to a nearby restaurant and we practice group riding, and the instructor always observes how the riders act. Until the end, at about 5 o'clock in the afternoon, then we close the course and we have certificates of delivery, and then we go back to the city. It's about 60 kilometers from the capital city of Pará and away. And we again observe the difference when we went to the training center and when we come back. These are some examples of exercises: static balance, slaloms, 90-degree pullouts and curves, U-turns, braking on a wet pavement, brake and escape or swerve. And these are some of the exercise patterns which are internationally used by the police, by trainers all over the world. In the paper there is a list of reference where you can see all these patterns there. There is a reference for that. These are some of them. And this is another example of the course held in another place. People from another city, about 300 kilometers from Belém, they wanted to have the course, and there were 12 people, so they didn't want to come to Belém, and we held the course there. And the people there just practiced always with the passengers, the pillions. So you can see here how to lift a heavy motorcycle, throttle and clutch control, offset cone weave with a pillion, the 90-degree pullout, and here's a young boy beginning very early to learn how to ride correctly. These are the conclusions. So the course is based on the experience that I've had for more than 40 years as a researcher, not directly in the motorcycle area, but it helps also. It's a lot of physics. And we'd like to emphasize the importance of teaching the theory consistently before going into the practical part. And we have seen that the participants make quicker progress when they understand why they are doing a specific exercise and the principles behind it. The exercise were adapted from many years of experience as a motorcyclist, taking courses in Brazil, as I said already, in the United States, and also practicing and instructing these drills. And the course has been applied successfully to all sizes of motorcyclists, as you've seen in the pictures, and you can see better in the paper, and different riders with different ages, different skills, etc. And at the end of the course, we make an evaluation from the participants, and sometimes we make some adaptations, some changes according to what they say. Well, that's all I wanted to present, and I'm ready for the questions if there are some.
So thank you very much for these interesting insights. First thing to mention, if I'm ever in Brazil, I will give you a call, because the pictures look quite interesting in combination with your approach. Seems to be an interesting thing to do. Besides that, I recognize that the topic of passing a license test versus learning to ride seems to be an internationally occurring, let's say, discussion. And I'm happy that we will most probably have some questions for discussion from the audience now, maybe.
I'd just like to say something about the examination. Examination for motorcycle riders in Brazil is very easy. You don't even have to put a second gang. No? Here in Germany, it's a little more difficult. I've made it here. I have also a Deutsch, German license, Deutsche Führerschein. I've lived here 5 years, from 1985 to 1990. I made my PhD in Aachen, and so I have all my driver's license here in Germany, and I know it's a little harder than in Brazil, but still very easy.
Thank you for that. Any questions? Yes, please. Oh, perfect. We actually have 2 questions in a row. It's the first time. Maybe start from the front.
Yes, my name is Berger from Robert Bosch. I was a couple of times in Brazil, and I think the main crazy situations I saw there are the motorcycle riding between the cars, the traffic jam, and they ride like hell between the cars. So, and the accident happened when a car changed the line. So I think I expect that also passenger car license should be aware. So by training the car driver to take awareness of the motorcycle rider, is there also some ideas that you extend your activity towards passenger car driver?
Yes, but the problem is to convince the people to do that. I've tried many times to put rider education in schools. Not only when you have to take your examination for the driver license, but also in the schools. And so that not only the motorcycle riders would learn something about motorcycling, but also the other drivers and the pedestrians and everyone else. Driving in the corridor, let's say, as lane splitting or lane filtering, is not prohibited in Brazil, but it's not regulated. And I'm fighting for that regulation because I think it should be, like here in Germany, people are also trying to regulate the lane splitting, but until now I haven't convinced the people, I'm sorry. And I always say, I always ask the people, what's the most important part of the motorcycle? And people say, well, the brakes and the motor, and I say, no, it's the part that stays between the seat and the handlebar.
No, it's not the fuel tank, obviously.
No, not the fuel tank.
Okay, yeah. Okay, thank you very much. The second question, please.
Good afternoon, Dolf Willigers, FEMA. When you mentioned preventive riding, I expected to hear a little bit more about behavioral aspects and how to behave in traffic and how to avoid getting into risky situations. But you didn't tell much about that. Do you pay attention to that in the courses?
Of course. Unfortunately, the time is too short to explain more about that. In the paper, you have more explanation about the preventive riding. But I introduced this concept, and I say it's divided in 3 parts. It's the before, the during, and the after. So the preventive rider starts before even you turn on your motorcycle. So you have to see if the brakes and the clutch and lights and everything is working, and if you, the rider, is also prepared to go into the traffic. So there is this first part, and then the during, and I discuss everything about that in the course, and in the paper I have also some information about that. Unfortunately, here we don't have the time for that, but I will be glad to talk to you about that later if you want.
Okay, thank you.
You're welcome.
Thank you very much. Maybe a last question.
Raphael Pless, WIVW, hi. You have stated that it is rather important to teach the students about the riding physics and all the theory.
Sure.
Can you maybe emphasize a little bit more on that? What is the main aspect that they are taking from that? What is the main issue that they are learning about, and maybe something that is new for them?
Yes. Most of the people, they have no idea how a motorcycle works, how a clutch works, or how the brakes and everything. So you have to teach everything to them. And also motorcycle balance, the physics behind it. You see, I've seen in many courses, for example, professional instructors saying that when you swerve, for example, that people use counterbalancing. I don't use this term because I think it's not counterbalancing. Counter-steering, I'm sorry. I think the Germans use the right term for that. They say Lenkimpuls. Because it's just an impulse. It's not counter-steering, as the people say. And they don't explain why. Some explain it's because of the gyroscopic effect. The gyroscopic effect has, of course, an influence, but it's not that makes the motorcycle incline and then go to the direction. There are other most important physics behind that. That's why I use a broom, for example, to show that. You saw the broom there. People say, wow, you're using a broom. Yes, to show that. And The other thing is that there is something that I learned here in Germany, a phrase that is appointed to Boltzmann, Ludwig Boltzmann, which is, es gibt nichts Praktischeres als eine gute Theorie. There is nothing more practical than a good theory.
Thank you very much. It was a perfect concluding comment for your presentation. So thanks a lot.
Thank you.
So we stick to the topic of rider training with the next speaker being Dr. Donald Green. Donald will be with us virtually, so he will probably appear in the next second right behind us here on the screen. Especially throughout the last decade, Donald gained quite some experience on adult education and he held various positions. That's good. Hi to the US.
Guten Tag.
Ah, sehr gut, sehr gut. Okay. I was just about to introduce yourself, stating that among other activities, you are the owner of Rider Choices Consulting and executive director of the newly founded PowerRide University. And we are very much looking forward to your presentation. So for the next roughly speaking 15 minutes, the virtual stage is yours.
Thank you, Sebastian, and good afternoon to everybody. Good to be here, even though it's virtually. I want to thank João for his kind of segueing me into this, because I think it's very important that we speak a lot more about rider education. I think it's underrepresented in conferences like these. So quickly, I will talk about the study that I just completed. It actually started in 2020, but the context of this is that in 2005, Dr. Raymond Ochs of the Motorcycle Safety Foundation surveyed the instructor trainers that we had within the system as to what they thought was valuable in the literature having to do with the competencies, characteristics, experiences, and abilities as instructor and trainers. I think it's a good segue from the last presentation that in motorcycle rider education training, we require good instructors with these strong competencies, characteristics, experiences, and abilities as attributes in order to teach new riders the valuable lessons that they will need to stay safe and stay alive on the road. So this is a list of some of the original literature that Dr. Ochs went through. It's still applicable for this research. And this literature was kind of broken down from these different areas. I don't expect you to read them all, but all these 40 competencies, characteristics, attributes, and experiences, abilities, were used by our instructor trainers in the original research and the new research to determine what was most valuable to know. I have taken it a little bit further in using what we call the 4 writing subtasks and broken it down into cognitive, social, emotional, and physical attributes. And I've circled the social and physical because I believe it's important to delineate in most rider education that there's a lot of focus on the physical, but really it's the social competencies of instructing and communicating and connecting with people that is extremely important to get the right messages across and change behavior. So the problem existed that we required these certain attributes to support a system of student learning. And this is because of the human element. I want to note that the human element is very important here because it involves those cognitive, social, emotional, and physical responses between the instructor and the student. And then when we get on the road after we graduate these courses, that's how we interact with other people on the road. And if you don't consider all the potential variables of each individual human, then the human element goes out the window, and we're only relying upon these other systems that we've talked about so much today to prevent accidents. So I have a definition of learning down below there. I'll let everybody read it, but I really want to touch heavily upon the human element during the training and how the instructor trainers speak with the instructors and how the instructors speak with the students and how that translates to safety on the road. The original population of the study in 2005 was roughly 215 rider coach trainers. Out of those 215, 32 respondents were the sample. And at the time, there were over 7,000 certified rider coaches or instructors within the system. In the 2020, the population of 210 was a little bit less. We had a sample of 34 respondents, so the population was represented a little bit better. But notice that 5,000 instructors were then available. So we've decreased the amount of instructors in 2020 from 2005, so limiting the amount of people available for training our students. These are just overall demographics from the study. The average participant was a middle-aged white male with a bachelor's degree and 35 years of motorcycling experience, 20 years as an instructor, and 15 years as an instructor trainer. And just to delineate this a little bit more, instructor trainers are the individuals who train the instructors who train the students. And I think it's important to talk about this cascade a little bit. In the United States, we train about 400,000 students a year. So roughly somewhere between 189 and 210 individuals training up to 5,000 instructors, training up to 400,000 instructors. So you can kind of see the cascade of the importance of having good qualified instructor trainers within the system. The method I used was a descriptive data analysis, rank ordered scaling with weighted relative frequency. So essentially there were 40 attributes we were looking at, and we had 34 different individual responses that were put together in aggregate to come up with the final result. For 2020, the results were very similar to the 2005 results. The top 5, very little change in the highest rated competencies, characteristics, experiences, and abilities. And the lowest rated CCEAs, the quick definition, were very similar to the ones from 2005 for the comparison. So in comparing the highest rated results from 2005 to 2020, you can see that there is very little change. In 2005, Understand Teaching and Learning Dynamics was number 5, and it went up to the number 1 position. So a nice increase there. Number 3 on 2005, the Evaluate and Coach Effectively, actually decreased to number 6. It dropped a little bit. And then you can also see a new one in 2020 with the Understanding Motor Skills Principles coming up approximately 5 positions. For the lowest rated results, you can see there's almost absolutely no change, just the swap of 39 and 38 in 2005 in position to 2020. So the significant findings was there was very little difference in the results from 2005 to 2020. There's a slight typo here. It's actually 77.5% of the answers were within 5 places of their previous survey. And I've described 3 down at the bottom, which were major increases. The conduct of the skill test proficiently decreased by 9 positions. So the value of that actually decreased. And then to screen candidates, that would be candidates to become instructors, declined by 11 positions. And I think this may be due to the fact that we are really struggling to find good, competent instructors currently in the United States. After the survey, the initial study and the weighting of all the answers, I did a post-research survey, and some interesting things came back in the fact that there was actually a larger response of people that actually participated in the original study or the new study. What was really interesting, 30.7% of the people that responded to the post-research survey actually said that they participated, but they did not. So there was a interesting response in the fact that we don't understand why they responded in this way. Overall, the importance of this is that when we receive all these different answers from so many instructor trainers, what we find out is that by aggregating the responses, it gives a little bit better acceptance of the answers as they're weighted amongst the entire data. The agreements and disagreements kind of neutralize, and the average is accepted by almost everyone. There has been a decrease in some of the answers in community and social aspects of instructor interactions. What I think is possible here is that with the pandemic and the separation of the connection of being with other humans, that may be showing through in some of the responses. And then lastly, the dissonance of the answers, the 30.7% of the instructor trainers who stated that they participated and did not, is kind of an interesting result of the survey. So in conclusion, what we have come up with is now more questions than we have answers of what makes a good instructor trainer. The competencies, characteristics, abilities, and experiences that are necessary to translate a good theoretical curriculum to the student so that they can go away with a better understanding of how to ride a motorcycle and be safer and reduce risk. The baseline of these questions is still good for instructor selection, and the answers are still a representative of the instructor-trainer culture. To continue on this research, we just started another evolution of this, where we're asking the instructors, the 5,000 instructors, the same questions to see if they have a different opinion or a different take on what it makes or what it takes to be a good instructor. And most importantly, this kind of identifies the human elements as a key component of the system. So one thing I'd like to say here that kind of follows on with the previous presentation is that it really highlights the rider training and education and the human element of riding motorcycles is possibly the most important component of a modern transportation safety system. If a good instructor accomplishes their job improperly, the risk becomes much greater. Whereas if a good instructor accomplishes the theoretical tasks and the physical tasks of riding a motorcycle properly, it becomes a much safer system. So I think that later on you may receive another presentation about some of the challenges in future rider training in the powered two-wheel community in Europe that may suggest some of these very same things. And barring anything else, that's the completion of my presentation.
So thank you very much. Thank you very much for this interesting presentation and getting up early for us to join us. Perfect. So let's see whether we have some questions from the audience. Or even from the virtual audience. So if this is not or not yet the case, please allow one question from my side. Because interestingly, the top 5 competencies or abilities that you showed reflect soft skills, let's say, of education or adult education that are not at all related to motorcycle riding. So my question would be, from your experience, how would you rate the importance of a trainer instructor being able to demonstrate maneuvers, for instance, with regard to his or her street credibility from the participants, let's say?
Interesting question, and I appreciate it. What I would say is that the competencies and abilities of riding a motorcycle are addressed within the 40, but what we have found out in providing so much rider education training is that if you cannot connect with the student, if you cannot have those soft skills, then the translation of the physical skills doesn't happen quite as well. And part of that is being able to coach or talk to the student in that soft manner about how to improve those physical skills. So an instructor should have the basic competencies of riding the motorcycle as well as the theoretical knowledge of why things happen the way they do, but without the soft skills component, it doesn't translate well in the educational sphere.
I see. Thank you very much. Which is somehow the same message, let's say, that you had in the presentation before, though. That is good to see. So any other questions to Donald? If this is not the case, there is one, please. Just a second. The speaker is on the way to the microphone. I'm not sure whether you can actually see us or just hear us.
I can see you, and it's a wonderful audience.
Sure it is. Yeah. So, hi, please.
So, Abdelkarim Aitmouna, University of Gustav Eiffel. I have a question about riders. So, how can we differentiate between experiences and novice rider? It is with annual mileage or riding experience. So, how can we make this?
I'm trying to interpret the question a little bit better. The difference between the novice and the experienced rider comes through really quickly in the educational sphere. With most of the novice rider training in the United States, it's very novice. And just like the previous presentation, there are students who don't know anything about a motorcycle, how to operate any of the controls. So that makes novice rider training very difficult sometimes. Whereas with the experienced riders, the normal training goes rather quickly, but rarely do those people come back once the initial experience to higher levels of training. There's no impetus for them to come back. So miles traveled, I don't see much of a correlation in novice rider training with miles traveled.
Okay, thanks for that. I think in order to somehow stick to the schedule, please give a hand for Donald again. And so have a nice day ahead, and I invite you to listen to the last presentation of this session, which comes from Nicolas Häffner. He unites a very big field of research at the moment, namely machine learning, with the potential benefits for motorcyclist safety. Nicolas is a PhD candidate at the University of Duisburg-Essen and working for the two-wheeler and power sports department at Bosch. His academic background is mechanical and process engineering from the Technical University of Darmstadt, where we've already had the chance to work on the same project. And as you came back from Japan last night, we are happy that you are awake now for us to present. Makes it easier. And we are very much looking forward to your presentation.
Thanks a lot. Yeah, I think I had the longest arrival, but yeah, bear with me. I have a topic that is a little bit off of the rest of it, and I think off of your expertise, at least most of yours. But bear with me, I think I can make it work. First, something that you are familiar with, probably most of you at least, is introduction to motorcycle ABS. The ABS is a wheel slip controller that mitigates the lockup of the rear wheel. On the right side here, you see a typical friction coefficient slip relation marked with the optimal area for ABS control. Afterwards, you will slope down into the blocking wheel, which makes the whole control quite challenging, because if you apply a constant brake, you will inevitably go into a blocking wheel. And as we all know, this is quite challenging to control for the rider of a motorcycle and might lead to bad crashes. We have some motorcycle-specific challenges that we have to deal with. Namely, in comparison to the four-wheeler department, the slip estimation is quite more challenging, since obtaining a reference speed with half the wheels is difficult, and we cannot afford to underbrake one of the rear wheels in order to obtain a new reference speed if we think it might be bad at any given time point. Then we have the whole topic about dynamic overbraking of the front wheel. For the motorcycle, since you have to do a lot of pitch motion, depending on your bike setup, but let's assume you have to do a lot of pitch motion in order to build up your normal force at the front wheel, but you can basically arbitrarily fast build up brake pressure. You run into a situation where it's quite easy to overbrake your front wheel in emergency situations, and that's something the ABS has to deal with. Another thing the ABS has to deal with that's motorcycle specific is a lift up of the rear wheel. Since we have a short wheelbase and a high center of gravity, it's quite easy to lift up the rear wheel, and ABS suppliers usually consider this as part of the ABS, and so do we at Bosch. If we look into the state of the art regarding wheel slip control, this is part or an excerpt of on a survey on wheel slip control design, so everything there is in research right now. I'm just focusing on the rule-based approach. That's what we have in production right now. That's the typical thing of that's different now. Depending on the state of the wheel, I define heuristics that define whether I increase, decrease, or hold the pressure. You can see there that the amount of parameters for this approach is rather high. And by translation, the ease to tune, so bringing it to a specific motorcycle, is rated comparably low, which leads to a high calibration effort to bring it to a new motorcycle. Also, the implementation intensity is rated, the implementation intensity is rated rather high. That's because every exception to the norm you have to identify and fix manually, and this leads to really high software effort, and combined this can be prohibitive, especially for low volume projects. In this paper, they also state that a weak investigated direction, and just in the starting point of research and wheel slip control design, is the usage of reinforcement and deep learning, and that's why I decided to look into designing a self-calibrating ABS controller using exactly deep reinforcement learning. In order to get the theory a little bit straight, this is what's called a Markov decision process. It's the mathematically idealized form of a reinforcement learning problem. And there we have basically an agent that would be the controller that acts in an environment. It is provided with a state that basically encodes all your sensor data at any given time point. And the agent can act on the environment in order to change the state of it. During training, it is also provided with a reward signal. This reward signal encodes how good the state you just entered is. It won't tell you anything about the future. That's part of the agent to solve what might happen afterwards. And the objective is then to maximize the expected and discounted cumulative sum of future rewards. We call that return then. And it is discounted just intuitively. The promise of 100 euros today is better than the promise of 100 euros in a year, so we take that into account. For my simulation or my research, I use BikeSim and call it with Python that will basically make sure that I have this formulation of a Markov decision process. My state space is defined by what we usually find in motorcycles. That is the wheel speed at front and rear, and by extension the accelerations as well, and the longitudinal acceleration of the sprung mass. I can leave that out, and there was some comparison later what happens if I do so. And then the action space is defined by whether, I'm sorry, that the motorcycle or the agent can increase or reduce the pressure at front and rear in a space from -10 to 10 bars. If we look at the reward, and this is important as it basically encodes what we want the agent to do, I had a look at the friction coefficient slip relation over there again, and the main objective of the ABS is to maximize deceleration while keeping in a stable slip condition. And at that peak, that's exactly where we are standing, and that's why I based my reward definition on exactly the maximum deceleration at any given time spot. We have to be a little bit wary because the environment is basically integrating, because if we brake half as hard, the episode will take twice as long. I'm sorry, I think I'm really slow. The episode will take twice as long, and that's why I introduced a non-linearity in my reward function that will just incentivize the agent to go faster. There's another key thing you have to implement, or you have to deal with, and that's the partial observability problem of the wheel slip control problem, because the slip is not directly measurable. And usually reinforcement learning problems call for the so-called Markov property. That tells you that your state definition must be sufficient in order to capture the whole dynamic of the problem. And I dealt with that by adding recurrency, and this is the only real theoretical part of my presentation. Down there you see what's called the long short-term memory, and this one has a loop in there, and basically the agent can learn what to remember and what to forget about the state of the motorcycle, and by that means obtain a so-called belief state about the state of the motorcycle. Here you see a typical training. I have randomly initialized braking maneuvers in terms of friction coefficient, rider input, and rider mass. And in the blue, you see the braking distance in an evaluation run with fixed parameters. In the red, you see the proportion of time steps with a blocked wheel. That's just for tracking the performance over time. So yeah, that I can see what's going on. And after roughly 200 episodes, the agent has basically figured out a blocked wheel is not a good state. And then in the blue, you see that with more training, the braking distance in that particular environment will go down as well. Here we see some results now. This is an environment, you can see it in the gray plot, where the friction coefficient starts out at a 0.8, then drops to 0.4, and then goes back up to 0.8 again. And in the green, you see the rider input at the front chamber, and in the blue, you see it at the wheel. And yeah, you can see the agent is keeping the pressure in check in order to have a stable wheel while reaching high performance, high deceleration. And as soon as that friction coefficient drops, it will also drop the pressure and come to a safe stop. The second major instability mode is the rear wheel lift-up mitigation. And as you can see here, the agent is able to mitigate the lift-up of the rear wheel while reaching high decelerations An optimal behavior in this environment would be having zero normal force at the rear axle or at the rear wheel while not lifting up. And in the lower plot, you can see that this is reached at least in the first part of the brake. I've talked about how I can leave out or get in the IMU, the longitudinal acceleration. And here's a comparison for the rear wheel lift-up mitigation environment. In the blue, there's no IMU installed, and the performance gets a little worse, but it's also able to mitigate the lift-up. And then with that, I conclude my presentation. And yeah, thanks a lot for your attention.
Thank you, Nicolas. So I think there is some time for one or two questions if we are perfect and on schedule, but maybe there is. Yes, over there, please.
Urs Dobler, motorcycle driving instructor. You must allow me now to speak in German because otherwise I cannot transport what I want to say. I was on the Nürburgring Nordschleife in the training, and 150 people have been asking by... Jetzt bin ich zurückgefallen ins Englische. Das passiert mir auch als Motorradfahrlehrer immer wieder. Also ich war auf dem Nürburgring Nordschleifen-Training
bend and in the training and a driving instructor discussed how to brake. That was in 1998. And then 150 people said, you brake progressively with a bike, 150 people said. And our students, we said, we brake aggressively. And I didn't dare to oppose the instructor. And that's a problem in training in Germany. That is something that is traditional knowledge, which is no longer real knowledge. Because the best braking is aggressive and not progressive braking, and that is something that one day German driving instructors should learn for good. And that is a statement and not a question, I'm afraid.
To your comment on that, but thank you very much. Any other comment? Yeah, Flo, please.
So, Florian Scherer from TU Darmstadt. Hi, Nico. Hi. Thanks for your presentation. My question is, will your approach only be valuable for a development process, or will you be able to use it also during normal riding? Maybe you have two persons on a bike or only one, and then you could also do the same?
Yeah, that's two different questions, really. Because of the time restrictions, I couldn't go into detail, but this recurrency I have in there allows you to do that without actually retraining. I had in the evaluations, I had the rider mass different, and it's only the upper rider mass, and it's in a range of 50 to 150 kilograms. So that would capture all of this, and this recurrency allows you to do some sort of system identification on the fly without actually changing the parameters of the network, because doing that on the system, in the field, might pose a lot of challenges for functional safety and so on.
Yes, this would be my question. Thank you.
Thanks.
Okay, thanks a lot. So it is Raphael to have the last question for session number 2.
Again, thank you. Yeah, I wanted to talk a little bit more about the parameterization effort for your model. Is this like some physics-informed modeling? How much does your algorithm know about the vehicle parameters, or is that even necessary?
So the model doesn't know anything about the vehicle parameters, and I try to, in the first step, have in the simulation as many parameters randomly initialized per braking maneuver as possible. Because what the agent then learns is to cope with all of them. We call that domain randomization, and then just having the last step on the bike.
Okay, perfect. So I would say thanks very much, Nico. Thanks very much to all 5 speakers of session number 2. It was a pleasure, and I think now it's time for the coffee break. Thank you.
My name is Ray Ochs. I'm with the Motorcycle Safety Foundation. I'm pleased to chair this third session today. We have some exciting presentations. We're a bit behind schedule, so we'll go ahead and get started as quickly as we can. I would characterize these presentations, though, as really macroscopic. They're about the big picture of motorcycle safety programs. So our first topic today is BMW's holistic view of motorcycle safety. There's two presenters. One is Dennis Gerber. He is a concept engineer and project manager in motorcycle safety for BMW Motorrad in Munich, and is deputy head of the working group specializing in motorcycle protection. He has worked in many Asian countries regarding traffic telematics. Presenting with him is Ulrich Zoelch. Dr. Zoelch has a doctorate in engineering from TU Munich. He has been an automotive engineer with BMW since 1998 and senior expert in vehicle safety and advanced driver assistance systems. So let's welcome Dennis. Go ahead, Dennis, it's yours.
Yeah, thanks a lot for the introduction, Mr. Ochs. Good afternoon and welcome to the presentation, BMW's holistic view on motorcycle safety. So, as already mentioned by Mr. Ochs, it will be a collaborative presentation between Dr. Ulrich Zoelch, who is responsible for whole vehicle safety from the passenger car side, and myself, Dennis Gerber, concept engineer, motorcycle safety. So before we start with the presentation itself, maybe you wonder why there is an airplane on the initial slide. So there you see a test track from BMW side where we perform collaborative tests between our passenger car department and with our motorcycles to improve motorcycle safety. And by the way, there is a demonstration of the active safety systems this week, so there's a press event. So please stay tuned and follow the press, so there will be a press release soon. Good, but now back to this presentation, BMW's holistic view on motorcycle safety. So, as we all know, motorcycle riders are vulnerable road users, and BMW Group safety strategy stands for a collaborative approach between motorcycle and passenger cars. But if we consider the motorcycle-specific safety strategy, we actually have three main pillars which we are focusing on to reduce the risk for motorcycle riders. And those three pillars are technology, rider safety trainings. We had interesting presentations before on this topic. And last but not least, the personal protective equipment is also a major factor which contributes to motorcycle safety. And then if we see the other side, the automotive safety strategy, which we consider as the protection of motorcycle riders. So there we focus on the accidentology, including motorcycle-specific scenarios. And furthermore, we research on the effectiveness of active safety system. And last but not least, we do the implementation of those active safety system in the cars. And there we consider the motorcycle-specific characteristics. So from our perspective, only if we consider both of the worlds and bring them together, then we can have a holistic approach on the motorcycle safety. So to sum it up, BMW Group safety strategy is an overarching safety approach which takes the interaction of passenger cars and motorcycles into account. And BMW motorcycles are premium products equipped with state-of-the-art safety systems. And here on this slide, you can see a matrix where we allocated our three main pillars: technology, rider safety gear, and rider trainings into the categories safe driving, crash avoidance, crash protection, and post-crash. So we are convinced that rider safety trainings are an important factor to contribute to safe riding, and therefore we from BMW side offer rider camps also at the beginning stage, so during the driving license, but also for safety trainings and perfection trainings. And in addition, we have the so-called Ride Again. So this is for motorcycle rider which had a break of riding and then start riding again. So we do this in cooperation with the RDSC, and we think to have skilled motorcycle riders is really a major factor to contribute to motorcycle safety. And as explained in the beginning, technology is also a factor. I will not read out the complete list here, but to name a few, so the daytime running lamp to have a better visibility of the motorcycles is a factor for us. ABS Pro, we had an interesting presentation about ABS. And also, if we go more in the direction of crash avoidance, we have the side view assistant like blind spot detection, and furthermore the dynamic brake light, which detects hard deceleration and warns the following vehicles. And then, from motorcyclist perspective, for sure, it is always crucial to avoid the accident, but also if the worst case happens, we are very active in crash protection, so we are doing developments in the field of rider gear, so on helmets, suits, boots, and gloves, and so on. And which is quite unique for the post-crash topic from BMW Motorcycle, we have the e-call, the automated emergency call, and this feature is actually standard equipment in the absolute majority of our vehicle portfolio. So BMW Motorrad top development targets are to ensure rideability, controllability, and best ergonomics in our vehicles. And for sure, we are doing a constant development of new premium safety systems. With this slide, I would like to go a bit more into detail regarding accident research findings. We had a very interesting presentation by Hannes Fischer from the CMC, which actually supports our opinion. The results of the research of motorcycle accidents show that we can categorize the accidents into two main categories. One are riding accidents, and there the main cause is the control, the loss of the control of the motorcycle. And the second main category are the collision type accident. And there in approximately 80%, the opponent is a passenger car. So there we see a high potential that on the passenger car side, we can really reduce the accidents. And therefore, it's also a collaborative presentation with our passenger division together with Ulrich Zoelch. But back here, the influence of the rider is also an important factor. So riders are not the same as drivers. So we are talking about, on the one side, the high-risk riders, and they go to the limits of riding dynamics and vehicle technology on public roads. And there we have the issue that those riders are not reachable by legal and consumer test gradings. But, which is very important, most of the riders are safety-oriented riders, and there we really see that the riding skills are crucial. Therefore, we want to approach there with the riding education, and also, which is important, that the technical systems need to be controlled in order to benefit. So the riders need to learn to use the technology. So therefore, we set on certified rider safety trainings. So from our perspective, improving the rider skills through continuous rider trainings is the foundation to avoid all types of motorcycle accidents. And furthermore, we see a high potential in active safety system in the passenger cars. And there, Uli, I know this will be a bit tricky, but that would be good if you could take over, and the stage is yours.
Okay, Dennis, thank you. Thank you, Mr. Chairman. Please, next slide. Yeah. Okay. So, unfortunately, I'm not able to participate myself in Cologne because I was caught by some infect, even if I did not participate in the Oktoberfest, but anyway. So I try to go through that online. And as Dennis stated, my field of working is at Total Vehicle Safety Department at BMW, where motorcycle rider protection is my field of work. And in this department, we have a group function for the complete BMW group, which means that we are able and in charge to set up requirements also for our colleagues which develop automated driver assistance systems. And our goal in that field is to maximize real-world safety, not only to fulfill legal requirements and to fulfill requirements from consumer test ratings, but to gain a real effect on road safety. And also related to automated driving, of course, the goal is for us motorcyclists to save the necessary space in traffic for safe riding, even also in the future. And at the moment, we have the favorable situation that modern ADAS systems, advanced driver assistance systems in cars, provide huge chances to improve road safety, especially for motorcycle riders. Next slide, please. Thank you. So the left-hand side of this chart has been shown by Dennis Gerber. So on the right-hand side, I can report about the influence of the car. And as we could see, we took a deep dive in accident research. And as we already heard today, also from Hennes Fischer and other presentations, there is a ranking of severe collision type accidents, which is mostly the same, even if you look on different statistics. So crossing traffic situations and left turn or far side turn in the UK, far side turn accident types are the most accidents, especially if we are looking on severe accident types. And if we look on the right-hand side on the bottom, we could find out an also interesting outcome, because we could show there was a conference presentation 1 year ago from my boss at Visital. We were able to show that active safety functions show a very high potential, especially at these crossing and turning scenarios. And the reason for that is quite simple, because these crossing and turning scenarios have a very high proportion of severe accidents. We can gain a large benefit if we are able to improve our active safety functions dedicated to that special use cases. Pardon? Thank you. Okay. This is a summary. I think I can go quite briefly over that, where we took a deep dive in the AMUSE project, the European project, which was started by Euro NCAP, and we see in related to severe accidents with fatal and severe outcomes that the left turn across path opposite direction conflict is on number one of the ranking, and the sum of these percentages is 71% due to weighting, so the respective proportion of these accidents is even higher. It will be at 22%. And on ranking number 2, 3, and 4, we see quarter motorcyclist crossing use cases. Number 5 is the rear ender use case, quarter motorcyclist rear, and number 6 is turn across path, where the car driver makes a left turn or a U-turn and the motorcycle is approaching from behind. So if you look at that chart, we know which are the most efficient use cases to tackle. Next slide, please. We also heard today about some from some person that they are not sure how good onboard sensor systems in cars will detect motorcycles in the real world traffic, and therefore we checked it in test events in order to make sure that BMW's onboard sensor systems are working properly, not only related to surrogates or NCAP targets, but we tested them in the real world. As you can see here, 2 different cars, several different motorcycles, and we carried out several tests where we checked the detecting performance of the sensors in this realistic use cases, which were derived from the accidents which I showed you in the chart before, and therefore we could show that our sensor systems are performing well, and we can state that BMW's active safety systems are developed to detect real-world motorcycles and also scooters. So next slide, please. Thank you. And now I'm really proud to present you the capability of the newest generation of BMW's advanced driver assistance systems reacting on motorcycles. So we are, as you can see in the left box on top, we are talking about front collision warning and braking function for turning with oncoming traffic. This function addresses the situation that the ego vehicle turns left and overlooks an oncoming motorcycle. And this function reacts on oncoming motorcycles and also on cars, by the way, which are oncoming with a velocity of up to 100 kilometers per hour. And this function is basic configuration in the latest generation of BMW's ADAS systems, which was launched in 2021. We can see on the blue box here, this is the requirement from Euro NCAP, which will start in the next year. And we have here on this chess board like figure the real-world accidents which were examined by GIDAS in Germany. And as you can see, the Euro NCAP functional requirement will cover 29% roughly of that. And we extended our BMW system, as you can see in the black box, which will cover motorcycle target speed up to 100 and the ego vehicle speed of the car up to 35 kilometers per hour. and therefore we reach more than 80% of this accident situation out of the GIDAS database. And next slide, please, Dennis. And to show you the function on the test track, we have a video here. Where a motorcycle target accelerates to this 100 kilometers per hour. On the left-hand side, you can see the car, which is about to turn left. The car is automatically stopped by a braking intervention of the system. So not the driver is stopping, the AEB function is stopping the car automatically in order to let the motorcycle rider pass safely. And I think this is a function we can be a little bit proud of, and we hope that not only BMW but also other manufacturers will make progress in that field, and there's more to come. So thank you, and I'm looking forward to your questions.
Yeah, thank you. Thank you also from my side.
Thank you, gentlemen. Would anybody like to ask? Just step up to the mics, identify yourself. Oh, we have one from the panel up here. Yes, ma'am.
Thank you for a very interesting talk, and I agree, very amazing technology to be proud of. I have a question about the social implementation of such technology. So my concern is that motorcycle riders will come to understand that this function exists, which will increase risk-taking among some of them, or in a sense demanding the right-of-way even when it's not theirs, because they know this function will prevent the car from colliding with them. So I'm wondering if there's any discussion on collaborating with legislators to maybe create new necessary laws, or using onboard cameras on the vehicles in case of legal disputes over whether or not motorcyclists may be taking unfair advantage and, I don't know, stealing precedence in traffic conditions.
Probably I answer to that question. Thank you for this excellent question. But to be honest, we don't have this discussion right now. And as you know, if you look at the fleet of cars on public roads, it will take years or even decades if everybody drives a new car with the latest technology. But interesting point, probably it will come up in the future. Good point. Thank you.
Okay, thank you. So also a small remark from my side. So I think it lays in our nature that we want to avoid collision accidents, and therefore I personally really doubt that also if you're aware that a passenger car is having active safety system which are emergency braking in specific situations, this is so specific that I really doubt that motorcyclists will go further to the edge based on collision accidents. I can understand this question for example, for riding accidents based on technology in the vehicles, but for collision accidents, personally, I really doubt it.
Okay, we do have one from the audience. Please go ahead.
Well, hello, Pierre-François in Emotion. Thank you guys to make your motorcycle safer through your automotive sides of your activity. I was wondering, you were mentioning about trainings, and you guys are collecting potentially a bunch of data on motorcyclists. How about giving some advice to the riders based on the way they ride their motorcycles and get them better through the data you're collecting in real time with the motorcycles?
That is a very valid and very good question. Thanks for that. So from my personal point of view, this data which is collected by the fleet is very sensitive data. So I'm not quite sure if we could use it for the education. But in general, to improve the rider skills is one of our main strategies to improve motorcycle safety. I hope I could satisfy your question.
Okay, we'll stop the question. Thank you very much, gentlemen. Appreciate BMW's viewpoints on those. Okay, next up, excuse me, we will have the topic of current and near future challenges for PTW community in Europe, FEMA-FIM Europe Considerations. Again, we have two presenters here. One is Dolf Willigers from Belgium. He's General Secretary and lobbyist for FEMA, representing the European motorcyclists and advocating for their interests and rights. The second presenter is Christopher Otter from Switzerland. He's Public Affairs Manager for FIM and works as a global advocate for motorcycling and within the government body for motorcycle sport. He helps guide the UK government in their motorcycle strategies and with EU legislation. So, gentlemen, you can divide it up.
Thank you, Roy. So we can skip the next two slides, please. Sorry. I can do it myself, so we can skip this one. Just had the introduction. So we have heard a lot of interesting presentations today about research, about new developments. We as a riders organization, we don't do much research. We are on the other side of the table. First, we use their research in our work. And second, we represent the people who have to benefit from your research and from your actions. And the way we use the information that we get from your research, from your reports, is that we write, as is shown here, the position papers, which are, we come back to that, joint position papers of FEMA and FIM Europe. And we use your information, we use the reports for our lobby work at the European Commission, UNECE, etc. I first have to go back to our organizations, because we have FEMA and FIM have very different backgrounds. FIM Europe is part of FIM, the global FIM, and they have their roots in sports and tourism. And FEMA is an old school grassroots riders organization. So we have very different organizations, very different backgrounds, but we noticed that our visions are very much the same. And to look more into that, we decided to make a working group, that was in 2014, to investigate how we looked at things and how we could use that for our common work. So this working group started in 2013 and published the first set of joint position papers in 2015. And they were about 4 topics: vehicle technology, road infrastructure, the rider, and general mobility issues. And at first it was 9 position papers, 9 topics that they were able to find common ground, you could say. The work didn't stop there. The working group was left into a position. We had meetings now and then. We discussed new developments, and we decided to revise the position papers every 2 years. See if there needed to be changes to them. See if there should be new position papers, or maybe position papers removed from the set. So this is an image of our meetings, not very interesting. And I must say that our cooperation is not just writing position papers, it's also going to European Parliament, to European Commission, and representing the riders as one voice instead of two voices. So these position papers, like I said, they are revised every 2 years. Then we started with 9, it are now 14. And this has everything to do with the new developments, like ADAS, ARAS, connected automated driving cars, energy transition. These are all topics that we discussed and that we found common ground and wrote position papers. So Chris will go more into detail about that. So we should skip this picture, I think. Like I said, we go together to European Parliament. Unfortunately, because of COVID, we haven't been able to, Chris and I haven't been able to go to European Parliament and Commission together, so there's no picture of that. Latest development is that this summer we wrote a memorandum of understanding with a third organization, the United Kingdom National Motorcyclist Council. And from now on, the position papers and the lobby work will not only be from FIM Europe and FEMA, but also from the NMC. And with that, I conclude my part of the presentation, and I left to Chris to say more about the position papers themselves and go into more into detail. There you are.
Thank you. They always take wonderful pictures, don't they? Yeah, so now I'm going to go through every single point in all 14 position papers. No, I'm only going to... So I was originally going to do 6. I might cut it down to 4, depending on how much time we've got. So the first position paper is on powered two-wheelers and the safe systems. So this one is basically taking the safe systems approach and using it for the work that we've done to look at different aspects of road safety for motorcyclists. We looked, I think you'll probably be familiar with the Swiss cheese model of risk reduction, where you've got gaps in different layers, and as long as the layers don't line up at any point, you get away with it. So we'll start with the first point, is that the policy paper talks about needing to address motorcycles in policy, because a lot of what we do isn't addressed in government policies around Europe. This is a recommendation that goes back to 2008 from the ITF, International Transport Forum of the OECD. Something we've talked about many times before. We've had different national strategies in places. I understand there's one in Germany coming and some others in other countries, but generally speaking, it's always been a bit difficult to get motorcycles recognised in policy in the first place. On the vehicle side, there's less scope for vehicle-based interventions, because obviously on a motorcycle you don't have a lot of crash protection. There's no roll cage. We have clothing that does some of the work, but it's not a complete solution. So, as João said earlier, prevention is better than injury reduction. You know, post-crash care is important, but due to injury risk, prevention is more important. So we would advocate policies that are more focused on accident prevention rather than accident mitigation. Infrastructure currently around the world doesn't really address motorcycles. There's lots of guidance written. There's international assessment programs for roads that look at motorcycling, but it's not the first choice when roads are designed. They're generally designed to through flow of car traffic, particularly in urban areas. That needs to be looked at. We also want to look at measures to address other road users. So riders are not alone in the system, as interventions need to address other road users. We've heard a bit about how important interaction between cars and motorcycles is already today. And rider training should focus on risk awareness and management. Obviously, we'll a bit more on that later, but essentially it's focusing less on skills and more on hazard perception and dealing with the road as it is. The next paper is on advanced driver assistance systems, something we've talked about a lot today. Our position paper focuses specifically on systems for cars and trucks, so not the motorcycles. We've got to have a different paper for that. Essentially, we'd say that there's benefits to ADAS for the visibility of the motorcycle. FEMA Europe are members of the CMC, and so are FEMA as supporters, so we've got a lot of faith in that particular approach. But we also need to manage the transition, because we're not going to have all the vehicles, as just said, we're not going to have all the vehicles with all the technology in the first week. It's going to be bumpy. There's going to be some vehicles that have it, some vehicles that don't, so the systems need to take that into account, and so does the legislation. Human-machine interface is critical. We talked about that earlier today as well, where there's the warning systems need to not overload the drivers, and that PTWs are different. They're not. You can't take a technology from a car and stick it straight on a motorcycle. So these are all things you've already talked about today. But probably the interesting bit from our point of view is the retrofitting. It's quite keen to see if there is some scope for technology that works to be fitted on older vehicles, so that we can get the rollout quicker if it works well. Obviously that's could be technically challenging, but if it's a transponder or something like that, that could make a big difference. So this is the Advanced Rider Assistance Systems paper. It says a lot of the same things, but the key differences are really that we have existing systems that work well. Mostly they leave control to the rider, so things like ABS, essentially the rider is in control of it. Those are good. And that's how we prefer it. Rider must retain control of the vehicle. We're not keen on systems that take over the dynamic control of the vehicle. We'd rather that was left in control of the rider, because it could form its own hazard if you're in a curve or something. And rider-generated data should be secure and controlled by the vehicle owner. So this one is on safe infrastructure. So road infrastructure, as I said earlier, is designed essentially with twin-track vehicles in mind. All the testing and design, or historically, has been focused on cars. If you look at crash barriers, for example, test standards are focused on cars. Motorcycles don't have a roll cage, so external environment is very key to the motorcyclist safety. So poor maintenance is a very common factor in crashes. We see potholes and loose gravel and other things that cause many injuries for motorcyclists. So that has to be taken into account at the design stage, as well as a key part of government policies to maintain and look after the infrastructure they put in place. Removal of roadside obstacles, because as we saw, they can make a bad injury worse. The removal of raised lane separators. There's a lot of these creeping around where there's little bumps in the road to separate one lane from another, and obviously if you hit them at any kind of speed, they can destabilize you, and they can often be very difficult to see in the dark. Roads should be clean, and maintenance is important, and cleaning is part of that. And as I said, motorcycles should be considered at the design stage. Many schemes completely ignore motorcycles, and I've spoken to local authority officers over years, and then said this thing that you put in is, quite hazardous for a motorcycle. If you're coming around that corner, that's a big bump you put there for no reason. And I've been told it's not meant for motorcycles. Well, there you go, there's the problem. So this one is on road restraint systems, which is essentially a lot of the same points. They are all over the place. And they do need upgrading. So one of the key things we put on there is retrofitting of existing barriers where it's possible. So that's a policy we generally advocate, and a lot of work has gone into that in various countries, in Germany and Italy, I know. And the last one, initial training and licensing. So knowledge and attitude are a key output of training and the licensing system. At the moment, a lot of it's focused on skills, but being able to operate a motorcycle safely on the road is the key expectation. and the test should reflect this. It shouldn't be about going around cones and proving that you can turn left and turn right. It should be about being able to assess the hazards in front of you. A lot of the exercises are not always relevant to road safety, and some of them are not gender neutral. So the current motorcycle test we have in European Driving Licence Directive requires you to push a motorcycle backwards and forwards as part of the test, which for some people, if it's a large heavy motorcycle and they're a small person, that is very difficult. Instructors and examiners should be riders themselves. We surprise a number of countries where you don't even have to be able to ride a motorcycle to be able to issue test certificates. And graduated access should be simplified. That there is the UK's interpretation of the Driving Licence Directive over 5 separate flowcharts of how to get a motorcycle licence. As you can see, that could be quite off-putting to people. So we would like that to be simplified if at all possible. And that's it for me.
Okay, thank you, gentlemen. Couple quick questions. In their paper, they identified a plethora, a whole listing of countermeasures and considerations to have. The question I've got is, based on your experience with this, how can we as motorcyclists get a bigger voice to make some of this happen?
Shall I answer that one? Yeah. I think probably the easiest way is to join a motorcycle group so that they have better resources, and also to ensure that all the parties are working together. I think one of the things that Dolf didn't mention is we do have a very open collaboration with ASEM as well at European level. So we have the whole sector talks in one voice on most issues, and it means that when we go to politicians, the Commission, sometimes we get quite a lot of success we don't always expect so quickly.
What do you think is our biggest, you can go ahead, I'll just have a quick question. What do you think our biggest restraint is in making this come to pass? What resistance are you sensing?
I think it's the first point about motorcycles not being part of policy. So a good example here is the European Commission published its urban mobility framework, which literally contained a list of every single vehicle you could think of, including urban air mobility services and connected and autonomous vehicles. Didn't actually mention motorcycles. So it's just not on their radar. So you have to go in there and you know, include motorcycling in the first place.
More motorcycles, okay. Yes, sir.
Hi, Raphael again. Hi. You've talked shortly about retrofitting, and I would like to emphasize on that a little bit more. Do you see any initiatives in that direction, some push from the industry towards this direction?
Not at this stage, but I think it's certainly possible if we have technical standards for transponders or things like that they could be fitted to older bikes. So, you know, I have a 2017 bike. You know, in 5 years' time, I could fit a little box somewhere on it and speak to a 2027 car. So it's a theoretical thing that we'd like to happen.
All right, thank you, gentlemen. Thank you, gentlemen. Let's go ahead and thank them for their extensive work. Thank you very much. All right, next up we have Marilee Nugent from Italy. Dr. Nugent is senior researcher at the University of Florence, where she works in human factors research. She has a background in kinesiology and a PhD in human motor control from McGill University in Montreal. Her current role is with EC Horizon 2020 Safe Up, applying principles and practices of knowledge translation and exchange in the development of evidence-based training and awareness. Those strategies on vulnerable road users and safe infrastructure, especially regarding automated traffic, with a specialty focus on motorcycle riders. So, Dr. Nugent.
Thank you. I have to switch glasses. I just noticed the monitors down here. Lovely. Okay. First of all, I just want to say I'm very excited to be here at the conference. Thank you, Ray, for the introduction, and thank you, IFZ, for making this possible. So what I would like to do is, well, I was thinking, okay, what is my main message today? And I realized that I want to come here today and do some knowledge translation about knowledge translation and how this can help us to answer some of the questions and quandaries and gaps that we've been discussing. So I've been listening to all, it's nice that I came at the end. I hope you're not sleeping yet, but It's nice that I came at the end because I got to hear a lot of repetition about the things we're concerned about and a lot of focus on the motorcyclists and the drivers. But what I think is missing is the discussion on how do we insert ourselves into the greater context so that we have a bigger presence and so that we can address maybe some of the stigmatization and marginalization that's keeping motorcycles out of the spotlight in current and future planning. So, just briefly, what is knowledge translation? It's a whole field of practice and scholarly research about how to move the results of research into practice. So I think this is mainly the main gap that we've been noticing today. It's known by a lot of different names. One study identified 31 different terms, related terms, across 33 different organizations that practice it. So there's various aspects: knowledge translation, knowledge mobilization, implementation, tech transfer, and commercialization, depending on the stage of your research and the goals for sharing the information and the results that you have. This is a commonly referenced model of knowledge translation. It's called the knowledge to action model. And it was developed by the Canadian Institutes of Health Research. And the central triangle shows the progression from the research results through synthesis processes and knowledge exchange to create new knowledge, new tools, and so on that can be applied in practice by knowledge users. And it shows that the process is cyclic. Another important aspect of knowledge translation is that a lot of the processes are social. So again, I think this is one of the aspects that's been missing a lot when we focus on the engineering and the training. Obviously, training is social, but then motorcycling interacts with virtually every different aspect of society. So how do we make those connections stronger to have a bigger voice? Again, a little bit more description about what is knowledge translation. So it's, I can't read from here. It's sharing, and in other fields, specifically health and social sciences fields, it's been very highly developed and is often a requirement for funding applications. And it's often a requirement for career advancement in academia. Just a quick explanation about how it fits in with research impact. Knowledge translation and dissemination and implementation are prerequisites for research impact. So we can think of our results from research projects as the outputs, our deliverables, our papers, our conferences, our exchanges in events like this. Then the outcomes are demonstrated changes, so maybe how many people cited your research or how many driving schools are using your rider training program, and then the impacts or the consequences. But this takes a very long time to appear, and I think as we've all experienced, it's very difficult to measure the impacts of motorcycle safety interventions on the actual traffic outcomes and injury outcomes. So what I wanted to do today is challenge us all to think outside the box, to think about how we can address some bigger questions. So I guess my main one is, are we taking a big enough view and approach to motorcycling safety? Are we reaching the right people with the right research and the right messages? Are we delivering the right messages? Are we using the most up-to-date knowledge and methods? And I don't mean just inside engineering and motorcycle research, but beyond. Do we understand the barriers and facilitators? Ray, you just asked a question about that. The barriers and facilitators to the uptake of our knowledge. So I feel like in a way, we're here today and these 2 days, and we're all preaching to the converted. We all agree. So how do we get to the people who really need this information? So, and how do we direct and apportion our efforts effectively? So here's one model towards that end. So again, my second purpose here today is to bring you the idea that there's a lot of frameworks and practices and experience and models and tools out there that can help us to do all these things. And that's an area that I would like to move into increasingly. This is a model from an organization in Canada called Parachute. It's a charity devoted to injury prevention. Note that we don't say accident prevention. I'll get to that in a minute. So they've created a model that looks at cross-sectoral collaboration in road safety. They also have a wonderful Vision Zero program, so I encourage you to check out their website on that. And they do evidence-based policy and education and guidelines to reduce injuries. So this model also sets out recommendations and steps that can be taken. So I'd heard about knowledge translation a number of years ago, and I finally had the opportunity to apply it to motorcycle research. In this project, SafeUp, the original call defined that training and outreach should be combined in a holistic approach towards addressing future risks in relation to increasing penetration of automated vehicles. So I was recruited to draft part of the proposal for the work package devoted to this. And this is just a quick overview of the design of the project. So there's a number of technical packages looking at protecting the safety of people inside and outside of vehicles, to be implemented not only in fully automated vehicles, but in intermediate stages of automation. So enhanced sensors to deal with problems of detection of objects in bad weather is one of them, enhanced algorithms and avoidance functions, and then CITS connectivity to provide timely warnings to vulnerable road users. And then something we're not as interested in is the passive safety for the vehicle occupants. I'm just going to skip through this. The idea was that I'm supposed to create some training guidelines for PTW riders in future automated traffic, but we're still waiting for those results to come from the project. So in the meantime, I'm working on an approach using the currently identified critical scenarios. So our familiar friend, the GEDIS database, was the informant for this analysis of one of the partners in the project, just to come up with the latest statistics on car to PTW crashes. And then another colleague of mine at UNIFI did a separate project looking at the MAIDS database, and his focus was on the errors committed by drivers and riders that are the causal factors in crashes. So my first question for us all, you can think about this and maybe respond later, either in the question period or contacting me individually, is this information is a big repetition from what a lot of people have presented. So why hasn't anything changed? Oh, I also made a point here to add a driver to the car so that we don't think about cars versus riders, we think about drivers versus riders in crashes. One of the key tools that I've been using in my work for this project is a template called the Knowledge Translation Planning Template. And what I really like about this is it has a very clear logic for how we need to think about planning for targeted dissemination. So beginning with project partners, a key aspect of knowledge translation is to involve stakeholders in the research process. So not to wait till the end to deliver the results. And the reason for this is it's important to have their voice, their expertise, and also to create buy-in and ensure that the results will be a good fit or will be accepted and useful. So these are the 13 aspects on the plan, and I'm going to focus a little further on 5 to 8, which I see as the kind of the core aspect of translating research results. So, but first a little bit about engagement. We want to think about who can use the knowledge that we're going to be generating, who can ensure the project's success, and integrated knowledge translation is a best practice approach. You could involve the stakeholders at the formation of the research question or just after and throughout the project. And I'd like to invite anybody who's interested in becoming involved in what I'm doing with SafeUp. You can click on the questionnaire link and fill that out, and I'll set up a meeting online. So far, I've been engaging with these organizations, so the International Federation of Pedestrians, European Cyclists Federation, FEMA, European Driving Schools Associations, Paulus, Urtico, European Transport Safety Council has a wonderful program for a guideline for creating traffic and safety education in schools for the future drivers, which I think is very, very important. And also, I've had some conversations with ACHEM. My vision when I was writing this part of the proposal for the grant for this activity was to try to get something started that could have a life beyond the project and be able to continue leveraging the knowledge translation knowledge for motorcycle safety. So an important step is identifying who the potential knowledge users are. So we don't want to think just about the end users. There's been a lot of focus on the riders and the drivers as the people we have to target for training. I would like to suggest that there may be other levels of the road system that need to be targeted for training. This is just, I'm going to skip by this a little bit. It's just a nice little metaphor for making our results palatable and translating them so that they'll be actually used. So you go from data, which is the ingredients, you put them together to create the cake, that's the information, then you put on the icing, you craft it in such a way as it's going to be appealing and it's going to be something that people relate to and want, and then if they eat it all up, then you've succeeded in delivering some knowledge that will be used. And the next step is to create a main message out of your results, so something that's very clear and actionable and audience-centered, user-centered. And we can think of, depending on the level of development of the research, it could be just at the information level, or it could be something that's ready to implement, like maybe a new aspect to rider training. And then it's very important to determine what the knowledge translation goals are. Do you want to inform? Do you want to educate? Do you want to see a behavior change, a policy change? So what I like about this approach is the clarity it brings. Just recently I was having another conversation with my colleague in my work package. She was focusing on training as a goal, and it's not a goal. Our goal is safety, improved safety, and training is a strategy. So I think it's very important to think with that clarity, because if we start from, we have this research, we want to have a safety result, okay, we start to think about who can use that information to have this impact, who has the power to put it into use for real impact, and how can we train them? How can we help them to understand how to use that information? And then knowledge translation strategies, these are a number of examples of what they could be. And I put this little symbol, more of a circular, interactive look at how the main message, the knowledge users and the knowledge translation goal need to be thought of together. So here's an example from the results that I showed you earlier in the infographics. I picked as knowledge users our partners, such as the safety partner network that I've been developing, educators and driving instructors, and the road users themselves, so unprotected road users and drivers. So here is a potential main message. It may not be the best. You might have a better one or a different one. New findings explain the most frequent and serious crashes between PTW riders and passenger car drivers and the mistakes they both make. Use this knowledge to anticipate hazardous situations for motorcyclists and to make better choices to reduce risk. So I was thinking of addressing both motorcyclists and drivers with that message. So my goals would be to generate awareness, inform, educate, impart skills, and promote behavior change. And then possible strategies, so tailored materials for the different audiences, infographics, and some, the main thing I want to develop is some animations based on the crash reconstruction data that can give multiple user points of view for how a crash occurs. And I'll be developing an interactive learning module that's supposed to target the multiple levels of cognitive processes, from just understanding all the way up to creating and reflecting on one's own behavior. So something that I got from interacting with the different stakeholder groups in road safety, because our project is not just focused on motorcyclists. In fact, it's more devoted to pedestrians and cyclists. As usual, the part for PTWs is minimized. I wanted to understand the context of the road safety world, because it's not my background, and I discovered that there's all these initiatives and programs and directives in place, and I wondered why these weren't being referred to and our efforts were not being contextualized in these. So this, I realized, was very important, and the partners I was connecting with, specifically from the pedestrian and cyclist organizations, were talking a lot about historical discourse, victim blaming, and mental attitudes that privilege car travel that has contributed to creating an unsafe system. Okay, so, and they also talk a lot about word usage. They prefer talking about road danger as opposed to road safety, because really the problem is there's a lot of danger and it needs to be addressed. And so today, the safe systems approach is at the center stage for road safety policy. I think this is really important to keep in mind and something we can link to and leverage. 6 pillars of the safe systems approach is at the top, road safety management. So that's number 1 for responsibility for creating a safe mobility environment. And then safe roads, safe vehicles. There's been a lot of discussion today about technology, so that's where the safe vehicles category comes in. Safe speeds, because we know that if you hit somebody at lower speeds, there will be less damage to the body. And safe road user behavior. So here's where education comes in, but I would like to point out that it's 5th on the list. And post-crash care. And then I just wanted to get an image to go with this list. And so I Googled safe systems approach. And if you notice that on all of these diagrams, except for one, there are no motorcycles. So again, we're confronted with this issue of motorcyclists being overlooked. How am I doing for time, Ray?
Well, you're catching us up. 2 minutes.
Okay. So another area of information that I came across was the importance of language use in talking about road crashes. I need you all to understand we can't use the word accidents anymore. And the reason is it's not scientific, it's superstitious. It's based in superstition. Because to say something is an accident is to say it's like an act of God, it couldn't be avoided. When we know from all our crash epidemiology and our research that crashes are predictable. We have all the statistics. We know why they happen and where they happen, so they're predictable. So going from that, then we start to look at the whole system. What can we change about the system to change those statistics? So it's very important to look at the language we're using as well. There's research that shows that if a crash is reported as a car hitting a pedestrian, there's an unconscious tendency to ascribe blame to the only human actor that's been mentioned. Okay, so now the current practice that's being promoted and put in official style guides of journalistic organizations is to use specific language that make sure that there's no unconscious biasing and placing of blame. Again, motorcycles are not listed, so here, this could be a collaborative project that we could work on together. I just did this is just another example of how you can change the language to be more acceptable, to remove bias in terms of blame. And this is adapted from a paper on the history of the paradigms of road safety. So originally, and I've just put my own versions according to the motorcycling perspective. So originally, back in the early 1900s, it happened because it was bad luck. So I put, okay, the message there could be, if you ride a motorcycle, sooner or later you're going to go down, ride at your own risk. Then we're moving forward, and the interventions became focused on education and punishment. So the person who's in the crash is responsible for their own safety. Then we moved to a period of more focus on engineering and continued education and enforcement, then onto technical solutions. And finally, we're in a period which I feel like as a motorcycle research group, we're not really up to date with. This period is saying that we need to look at the entire system. We're not just talking about infrastructure. We're not just talking about speed limits. We're talking about social values. We're talking about attitudes. We're talking about legislation. We're talking about how much funding is given to motorcycle research versus other types of injury prevention or disease prevention. Is it being apportioned equitably? Those are just a few examples. It would have been nice to do an exercise, but this is more for a workshop. When we try to contextualize what we're doing and what our research is in terms of the current paradigms, how does this change how we think about who are our target audiences, what is our message, and what strategies can we use to get through to them? So I'm not sure if I should leave it there. I could leave it there. I've got more slides that you can see later. I do want to put in a plug for this book. I really recommend that we all here read this book. I've talked to this woman. I've watched a few interviews with her. She really does a great job of deconstructing the psychology and the paradigms behind how we think about crashes and about who really has the power to change road danger. And I can't say enough good about this book and how useful I think it will be for us. Okay. So that's my last message is maybe we can think about a paradigm, catching up with the paradigm shift that's going on now.
You good?
I can, yeah. So I have some recommendations. So partner with other unprotected road user groups and learn from them to find common goals and objectives for mutual support. So I'm wondering if we can partner with other groups and become part of the planning on a whole for mobility, and not just think about motorcyclists in a separate lane, but think of how we can be included in the planning and strategies for infrastructure and furthermore, there's a lot of tools we can use, there's a lot of precedents, and there's a lot of expertise that can be leveraged from the knowledge translation field. And I have lots of references for you. Oh. And that's my contact information, so please do reach out. Thank you.
Thank you, Dr. Nugent. You gave us a lot to unpack there, and you did ask us some questions, so we got maybe time for one or two questions and one or two answers to some of her questions. Any comments? Go ahead.
Good afternoon, Matthias Berger from Bosch. You just introduced a new abbreviation, URU. It took us a while to introduce to the four-wheeler community the terminology VRU. Why do you change again into something which currently nobody is using?
That's a good question, and it was partly the feedback I got from the people I was engaging with, the organizations I was engaging with. The reason that they don't like the term vulnerable is it's sort of ascribing vulnerability as a basic human state, when in fact it's just the result of what happens when cars and pedestrians and cyclists and motorcyclists are put together in the same area and without the proper protection. So vulnerability shouldn't be a stigma. It shouldn't be something. We're all road users of different mode types, and when we're not in a car, we have less protection. So it's partly to make less of a distinction between different road users, because we all share the different mobility types. But vulnerability is not it's not a problem to be solved, essentially, from the point of view of the person who's vulnerable. So the preference is unprotected.
Just one short statement. It took us months and years to introduce this terminology or this short form into standards and also into regulations. And so I try to promote that we at least stick to some of the common terminologies for our safety in future. Thank you.
I think I agree, because after the fact, it didn't seem to be worth spending the time on the terminology. It's more important about what people's actions are. Thank you. Was there another question?
No, I think we'll stop with that one. We've got to leave a little bit of time for the closing remark. Let's give a hand for the panel getting us almost caught back up. So with that, we'll have a few closing comments and then some information about tonight, I think. So.
Thanks, Ray. Ja, auch von meiner Seite aus nochmal ein herzliches Willkommen zur 14. Internationalen Motorradkonferenz.
Welcome to the 14th Motorcycle Conference. It's good to be in Cologne again, and I would like to welcome the remote participants. After a day with insightful talks, I'd like to say that if you want to go in more depth, you will have at the IFZ website all the long versions of all these papers available for you. First part of today is over. There was highly interesting developments and insights have been presented to you, and signify development for us. The journey continues, the dialogue will continue in order to exchange more, to freshen old friendships after 4 years. We will meet for this purpose tonight at 7 o'clock at the Frühkölsch in Dom, and there's information on that. So the direction is not included in the program. So I will be able to announce further exciting talks for tomorrow, giving us more insights on the future of safe motorcycle riding. The ASIM will be discussing with industry representatives and politicians, discussing a vision towards sustainable mobility in Europe. ASIM General Secretary Antonio Perlot will be the host of that panel. The details on the roundtable discussions you can get from the program. And I'm now looking forward to a very, very exciting, entertaining evening program. And tomorrow we'll continue at 9 o'clock here in the Rhein Hall. So the new research paper, a magazine rather, will be a very interesting collection of topics for all of those who want to go into more detail regarding the topics raised. I would like to also thank at this point our hosts of the sessions who have done a perfect job, and I would like to ask for a big applause for the moderators, for the heads of the sessions, and so for today, we like to say farewell to all those who have joined us at the screen. Whether this is a good night or a good morning, it depends on the time zone you're living. And at that point, the only thing that's left for me to say is to thank you for your attention, for a great first day. Yes, I'd like to point your attention to tomorrow's another great conference day. Thank you very much, and see you later.